Hello and welcome once again to episode 33 of Code Completion. We are a group of iOS developers and educators hoping to share what we love most about development, Apple technology, and completing your code. My name is Dimitri and I'll be your host once again for this episode, and I am joined today by my fellow completionist, Spencer.
Hey there.
So before we get into our main topic, it's time for our Indie App Spotlight. First up is Worth It by Maxime Mazzone. I hope I got your name right. I'm so sorry if I didn't. But it's an iOS app that helps you track where your money and accounts are and gives you detailed graphs that help you track and analyze your net worth over time. Worth It even reminds you to update your data so it continues to stay accurate and works across multiple currencies, making it a great way to keep tabs of old accounts and investments you may have otherwise forgotten. You can support Maxime by becoming a Worth It member, and you can choose to pay anywhere from $10 to $20 for that a year, because it's a pay what you want model, which I thought was pretty cool.
Mm-hmm.
And finally, we have Unwind by Kushagra Agarwal. And once again, I'm sorry about your name. An iPhone and watch app that helps you wake up, focus, and sleep better through mindful breathing exercises. So it's like the Breathe app on your watch, except it's like way upgraded. So Unwind coaches you through 3 guided breathing sessions that are accompanied by beautiful illustrations and sound effects to help you start your day fresh, relax and unwind, or get ready for bed. Unwind is free to download, but also comes with a $5.99 in-app purchase that unlocks all ambiances and gives you access to the full history of your exercises. So please give it a try and support Kashagra. And if you are an indie developer, we want to hear from you. Please reach out to us on Twitter at Code Completion via DM so we can spotlight your app too in the future. So on to our main topic, we thought it might be a good time to go over everything server-side Swift. So to help focus that a little bit more, Spencer, care to take it away?
Yeah. So with server-side Swift, as I was kind of thinking about what to talk about for this episode, really one of my big things was, why would someone, your average iOS developer, want to get into server-side Swift? What is it? It's this thing that's a little bit outside of the realm of the Apple ecosystem, iOS, macOS, that we're all kind of in on the daily, whether it's learning or also for our jobs. So what benefit, is there for you to sort of jump outside of this bubble that we're already so used to with all of the frameworks and everything,
Mm-hmm.
and learn, right? And one of the biggest things for me was it is this sweet sort of bridge between what we do know,
Mm-hmm.
which is Swift and Objective C and everything, and we're doing that on the daily. And most of us, I think, are probably using Swift at this point. Uh, Server-side Swift allows us to do things that are still Swift. It's in the same language, but with a completely different functionality. So it's I think of it more or less as web development for iOS developers, where we can do some of those things that they do, front end development, back end development, really both of them. But we don't have to go through the struggle of learning JavaScript or learning, also more, frameworks like React or something in order to build sort of like a front end and back end. We can already use the language we know. And that's sort of
Mm-hmm.
what tipped me off to wanting to learn about it was when I was learning iOS development, really enjoyed. Also, I thought it was hard at the time, but I enjoyed consuming REST APIs and interacting with them because I thought it was a way for me to get out of, what can I do for my app, but also leverage all of the work that other people have done. So server-side Swift is this cool way to say, okay, I, for example, kind of really the first couple, I don't know, backends that I used that were kind of customizable were, of course, like Firebase and CloudKit, which they're great, but they have limitations. Both of them, they have their
Mm-hmm.
own limitations. Um, but you don't have a ton of how would I say this? You don't have it. It's not very customizable. CloudKit's pretty dang good. It's, it can do relationships and everything, but there are still some limitations where with server-side Swift using something like Vapor, you're basically in control. You can choose to make your server-side application just a back end, just a front end, do both. You can make the endpoints and have it do complex operations, not just sending things, getting things in sort of this database, but it can do anything. And we can get into that more, but it really is a little bit more flexibility and power to you, the developer, to make whatever you need and to make it fit your needs better, if that makes sense.
Yeah.
That was a lot, though.
Great summary. So there is an elephant in the room, and I think most people will ask immediately, is server-side Swift production ready? Is this something that I can go ahead and rely on? And I just want to get that out there that it is 100% production ready. Both of my jobs, I have 2 jobs, both of my jobs have a server-side Swift component to them, and rely pretty heavily on those components. And it is more or less rock solid. So let's talk a little bit about the benefits that you get by building a server-side Swift. As you said, Spencer, it's immediately familiar for you, an iOS developer, but an iOS developer is not necessarily going to make a very robust backend. It's a different set of skills that you have when you're designing user interfaces, and tweaking those animations to be just perfect is not the same exact set of skills that you would use writing a backend. That said, once you do get acclimated to that way of thinking, we're going to go a bit into how it's different later. But as you do get acclimated to thinking that way, there are some benefits to writing your code in Swift over something like Python, which is a very common language for writing backends in, JavaScript with Node.js. Swift is a compile language, which means that you can get a lot of performance out of compiling your code and not necessarily letting it be interpreted at runtime. And because Swift is a statically typed language, that means that the compiler can take a lot of optimizations for you and really speed things up. So you can get a lot of performance out of a single Swift instance. And one of the major differences between a Swift server application compared to a Python server application or PHP or Node or what have you is every request that's coming into your Swift server application on your 20-core server machine is living in that same process. It is not split up amongst a bunch of different processes that don't really communicate with each other at all. You just have one process that's running, and it's taking care of all the hard work for you. And combined with some frameworks like Vapor, it really makes it easy for you to just handle a request that's coming in, do what you need to do, and give it back. And you end up with something that's very performant at the end of the day. Anything you want to add there?
Yeah, no, I just, I remember, and this was years ago. So server-side Swift has been around for about 5 years now, if I remember right. Yeah, since Swift was open source, they started, making things. And there were, I think, around 5 or 6 different kind of server-side Swift frameworks that were all kind of vying to be the top dog, right? And now we're at the point where Vapor is basically the only one that anyone uses anymore. Everyone, including IBM, has kind of canned their own implementations in favor of just kind of supporting Vapor. And there was this, I guess it was really like a table that showed performance between all of those different frameworks and Node.js. And Node.js never came in first for any of the performance statistics that were there. So it's like memory usage, thread usage, just benchmarks, how many requests per second could it handle, latency, JSON benchmarks, and they were all either beating or, well, Node.js was basically in the middle. It took 3rd place out of 5 in most of these. And that was 4 years ago when it was very much a it was very new. So I wouldn't be surprised if, like Dimitri's talking about, the benefits of having a compiled language being being much, much more fast. So the performance is there. It's not like we are kind of on this island where you've got all of the web developers in using all of those different languages that Dimitri mentioned, just absolutely crushing us. This isn't something that is just a fun to have kind of experiment with Swift. It's something that if you really wanted to, you can throw it on Heroku, or you could deploy it to AWS, I think, even now.
Mm-hmm. Yeah.
And there's like built-in tools to help you even deploy it yourself, and get something up and running. And really, if you're building an app that needs a backend, you could just write it yourself. I think that's a really cool benefit with it. I personally, I would use it for that. I'm not sure I would. Front end development is a little bit less interesting to me, but like Dimitri said, you get type safety, right? You can either use something like Vapor's own Leaf, as it's sort of this templating engine where you can combine HTML with these tags to kind of let things be dynamic within the HTML, or you could go a route like John Sundell's Plot. Is it Plot?
Yeah.
Or I forget which of the three there it is. Yeah, Plot. Where you're writing Swift code, but then it will translate it into HTML for you to display, and you get that type safety of making sure that you're not forgetting to close a tag or misspelling the tag. So some really cool things on that front as well that I just wanted to mention before we move on.
Mm-hmm. And to give it a little bit more context, so Vapor helps you build web applications, which you typically see whenever you need a REST API. But it's not limited to that. You can also go ahead and use WebSockets with Vapor and get access to that direct stream, which is very, very powerful. And it makes it very easy to set that up. So, for instance, in Vapor, if you have an API with like 3 endpoints, you just have to basically say this endpoint gets this function, and you're going to do something in that function and give back a result. And as Spencer said, since Swift is statically typed, you get type safety throughout that entire process, which means that you have less bugs in production than other languages. Other languages, you might have a more or less working thing, and then one endpoint is completely broken, does not compile. You wouldn't even know until someone hits that endpoint. With Swift, it catches that. It won't even let you progress, basically, until you fix that, which means that your service is going to be a lot more, a lot more stable over time, because Swift is helping you make it stable. It's helping you know what happens when there's an error. It's not just going to throw an error willy-nilly. You need to do something with the error, right? So you can pass it on. That's your choice. Or you can handle it and show a better error to the user and not just throw a 500 error and have the user just be confused that the server is not working. So I think that's one of the big selling points for something like Vapor. And as Spencer said, like if you are an iOS developer, you can jump right into this. It runs in Xcode. You can hit build in Xcode, and it will just start up a server, and it will log in the console. Hey, point Safari towards this, or point your app towards this, and you're good to go. And you have a local development environment just right then and there that you can go ahead and use. And I think that's a completely separate selling point. Most of these server-side development stuff, you are putting this on a server and you're hoping that everything works. And if something doesn't work, you log it and then you check the logs and you have to go through that cycle, put it back on the server, have 50 commits of maybe this fixes it. Whereas with this, since you have Xcode, you can put a breakpoint wherever you want and you can just stop everything. Like your app is waiting, it can wait 60 seconds for the request to come back. So you have 60 seconds or more. You can configure, it's your app, so you can make your app wait as long as you want. But you can basically have full control over what the app is doing, your server app is doing in that whole process. And I think that is magical. Like having a full debugger is really game changing for a lot of things, because then there's no more ambiguity as far as what's going on with what do the variables look like. You can see exactly what that is. You don't have to log it to a file and then hope that file does not get over 50 gigabytes large and then cause your server to run out of room. Like, forget about all that. You have something that's much more powerful at your fingertips, and I think that is one of the biggest selling points, honestly, past anything else. And one other thing I want to mention before we do move on is there are other compiled languages like Go and Rust, and Swift is basically in that same ballpark. Those languages I feel like are more tailor-made towards certain things, whereas Swift is very general, and if anything, it's tailor-made towards iOS development. But again, you can use everything you know from iOS development, like date, UUID, even URL session if you really wanted to. There are alternatives that are a bit faster. But JSON serialization, like JSON encoder and decoder, all of that still works. Like if you have a library, you can use the same library on your server side and on your app side. So I think that is excellent. So that's Vapor to build like a web backend. Of course, there are other solutions as well. Like you mentioned before, Spencer, Plot, which is a component to John Sandell's Publish, which is a static site generator. So it allows you to make something for the web, but it doesn't necessarily run any code on a server. It's all entirely in Xcode on your computer. You hit build and run, and it will generate a website for you based on the Swift code that you wrote to stylize your website. So we use that for codecompletion.io, and it works perfectly great for something simple like that, which means that the web server, which in this case is Apache or something like that, can go ahead and just statically serve files that are pre-generated, and that is all done using Swift as well. And like the web and servers are not limited to like the web server category. Like you can write any kind of server you want if you drop down to Swift Neo, which is non-blocking IO, and that's an open source framework that Apple publishes that fully backs things like Vapor and makes all of that possible. And you can write whatever protocol you want on top of that. It doesn't have to be HTTP. It can be literally anything. It will take care of the TLS, I think, the SSH and the TLS, transport layer security. Yeah, TLS. It can take care of all that for you. So then you just have to concentrate on what your protocol is designed to do, whether that's a real-time video and all of that. So I think that's the really cool thing about everything that's being built is there's a bunch of server-side components that all fit into each other, and they're all building upon each other. So no one's kind of working in isolation anymore. Vapor is the web backend for Swift development. Like you don't have to go hunting for which one do I use, which one is better or not. It's built on Swift Neo. It's not going to
change every year.
It's built on Swift Neo, and everything else server side is built on Swift Neo, so it all plugs in. If you want to do tracing, which I found out recently is super cool. It basically allows you to see every request that's coming in as it goes from server to server to server and back. And you can see this cool graphs on like the Amazon web portal and stuff like that. And you can know exactly what went wrong when you weren't looking at it. So it records all this stuff. So things like that just plug into everything. And you can go ahead and use them across all sorts of different packages. And I think that's the real cool thing and about the maturity of server-side Swift is that it is getting mature, and you do have a lot of packages in this ecosystem that are all working together.
Yeah, that's a huge part, and like exactly like you said, with both Swift Package Manager, everything uses the Swift Package Manager at this point. Mm-hmm. We're finally getting out of the hell that is CocoaPods and everything, so that's awesome. Going back to what you said about the stability. Not only are you able to put breakpoints, but taking it further, this isn't a Vapor specific thing, but you can have unit tests for your server-side code and have it test. Like that's the coolest thing to me is, when you're just doing manual tests, like it's awesome to have breakpoints, and we all do that. You can, go even further and just say, hey, I just made this new feature just like you would on an iOS app. There's nothing different. Let's run some unit tests, or let's write some more unit tests and have it all run within Xcode. So there's a benefit there as well, where we get the testing that we're used to, and it just uses XCTest. And I think there's a specific library that they've made for Vapor to help the testing of Vapor itself, but ultimately it's just using XCTest. So that's super cool as well. And like you said, Swift packages are amazing because people are coming up with different packages. For example, one that I used on a project that didn't actually end up going anywhere at Lambda School was hooking in really easily to Amazon S3, right, for storage. You've got that. You've got pre plot, which again is John Sundell's kind of engine to help you write HTML. There was I forget what it was called. I think it was just called HTTP-Swift or something, or HTML-Swift. I can't remember. But people are writing, because this is all open source. They're all writing their own helpers and ways to extend the functionality of Vapor beyond what it can do in a basic sense, which is actually quite a lot. But you can always, like Dimitri said, write whatever you need to, maybe not even having to drop down to Swift Neo, but doing whatever you need to. If you have an idea to make it better, you could submit to Vapor itself, submit a PR, or just, have kind of a separate framework that people can use and import. Are we done talking about Vapor? Can I mention one other thing real quick?
Go for it.
Okay. I just wanted to mention, because we talked about this being a backend, and I think that's probably its most common use, not necessarily a good or bad thing, is it supports a wide range of different databases. So you've got, NoSQL, you've got SQLite, you've got MySQL, Postgres, and I think now it supports MongoDB as well, which is awesome. You've got a bunch of options. So if you want a, they just call it a NoSQL database, like a non-relational database. You can do that. You can use SQLite if it's just something super light. You can have it running Postgres. I've used all three of those, and it's awesome.
And the coolest thing about those is they are built on Swift features. So you can use property wrappers to annotate what your object looks like in the database. So you write your struct, and then you say, okay, this property is tied to this field in the database. This property is tied to that field. And then the framework takes care of a lot of the details for you, and allows you to just bootstrap that development, so that way you don't need to know really what MongoDB is doing in the background. You can just annotate everything, and you have a basic database. Of course, to get good and to really eke out any performance, you need to know what MongoDB is actually doing. But the foundations are there to get started quickly, and the toolbox is there for you to really pop open the panel and start tweaking values and requests and things like that, so that way you can eke out as much performance as you need.
Yeah. I think of it more or less as what Core Data does for us, right? It's all using SQL databases behind the scenes, or SQLite by default, but you're never going into the tables or anything and doing anything there. It's just all kind of abstracted out for you. And like Dimitri said, the best part is really between all of those, I don't believe there's really any difference as far as the model layer goes. There's a little bit of setup that you have to do depending on which database you use, but other than that, the property wrappers are all the same, and it's made really easy. It's using key paths, and you're really not getting into very many stringly typed things. It's pretty clean and Swifty, which is again awesome, because that's what we're used to. We're used to type safety. We're used to using key paths, so nothing really feels out of the ordinary, other than getting maybe used to the framework itself and the file structure, because that's different. It's just in a package. It's not this Xcode project itself. But overall, the learning curve is much, much less than if you were to go out and try to learn, front end or back end development with just a normal language that you would do, like Python, PHP, or whatever. So,
yeah, definitely pre server side Swift. I have a few services that are written in PHP, and I'm terrified of needing to go back and maintain that because I don't remember how any of that works.
Right.
And every single time I needed to write a new one, I would go buy the most recent book of like what PHP and MySQL currently looks like, because it's been 5 years since the last time I even touched any of it. So it is definitely refreshing to use something that you use daily to build these components, especially if there's something simple and small. Like if you need to deal with in-app purchases, you don't need to use RevenueCat. The only part of in-app purchases that you need a server for is to verify the receipts and make sure that everything looks good. You can write yourself a really simple server-side Swift app that does just that. And it would probably be less than 500 lines of code, to be honest, because it's just that trusted third party that is accessing Apple servers rather than your app that can be spoofed in a million different ways if you cared about that authenticity for each in-app purchase. So it can be really something simple like that, and it's really dead simple to kind of get started with that. As you mentioned before, Spencer, we keep rewinding a little bit because we keep mentioning something, but then we have something to add. So rewinding a little bit, you mentioned that it's really easy to add things to Vapor, and I want to reiterate that. Vapor is not like UIKit. It's not a framework that you import and then it's just a black box. It is code that you import via Swift Package Manager, which means that if you have a breakpoint in one of your methods, you see all of Vapor's stack history, and you can just go up the chain and see the code that the Vapor devs built that got you to that point. And you can either use this to learn from it, or if you need to make something that's slightly different than what the defaults provide you, you can go ahead and just build that. All the code is there. All the code is very well documented. And there's a high level of like competency that went into building these projects. They're not just like half put together and just like thrown to the winds. They're all documented. The code itself is documented and clear and easy to read. And it's really easy to go ahead and add any extra functionality that you just might be missing. So I myself like ran into a few roadblocks, and it took less than a day or two to get comfortable with the code that was there, have a modification ready, submit a PR, go back and forth a few times to get everything that's needed for that to be pushed in, and then it was merged in. So if you're missing anything from the frameworks, and if you have a unique thing that you're building, you're sure to be missing something. But the foundation is really solid, and it's easy to build on, and it's easy to just push that upstream and have that be something that everyone can then go ahead and use afterwards. So I think that is a great thing to have.
Yeah. I mean, just going back to your point of, it being very well maintained, I don't know if this is still true, but for a while there was someone that was working full-time on Vapor. Even though it is open source, there are contributors who are, donating money. I think there are actually a few companies as well that are sort of more or less smaller companies, not like IBM. Yeah, they're sponsoring it, which is amazing. So, and it's very, very actively, it's very active in development. There are PRs going in all the time, not just from the normal maintainers, but also just people in the community. And that's the best part about it being open source. Like Dimitri said, you have access to the full stack trace. You can see everything that you need to. If you don't understand something, go look at the source code. It's not this black box like Dimitri said. So that's really cool. Do you have anything to add before we move on?
And one last thing to mention about contributing to open source. It is a great way to meet other developers, and if you're looking for work, it's a very easy way to get your foot in the proverbial door. So if you do contribute to open source, it's easy to put that in your resume. It's code that anyone can look up, especially if like there's a PR and you were polite and you had good code. Like that is the optimal scenario for you to get new opportunities, especially if you're just getting started and you don't have a ton of experience that's directly listed as like working for a company A, B, or C kind of thing. So if you are looking for work, helping out on open source projects, especially server-side Swift, projects is a great way to get a lot of eyes on what you're doing, and it's a great way to communicate with the teams that are working on stuff. And guess what? If you are actively there, hopefully for your own project that you're kind of putting together, and not just blindly like ticking off issues. But if you're actively there and there's an opening and you apply for it, they recognize who you are. Like that is an easy way to just fly through the process, and get an offer quickly. I mean, assuming you're writing good code. But like those are relationships that you're building.
Yeah. And at the absolute least, you are learning.
Exactly.
So
It's
not
win,
really
win,
a
win.
downside. Yeah. I mean, it's time, but other than that, it's pretty dang good. So moving on kind of with Vapor, but also tying in WWDC, async await is finally coming to iOS and everything, but also it's now going to come to things like Vapor. So Tim, I think it's Condon. Yeah, I can't remember. I don't know exactly how you spell it. He's one of the main maintainers of Vapor right now, and he's put together a branch of Vapor using async await, so you could go ahead and try it out and
Experiment
use
with
it
it.
right now. Unfortunately, I wanted to look at that today before the podcast. I didn't have time though. But let's kind of do a compare and contrast between async await and what is there right now in Vapor itself.
So I guess let's back up even more, and let's explain like how different is server-side development than iOS development. So
Sure.
one thing you're immediately going to run smack into a wall of is what is a promise and what is a future, and what are
Yes.
like why do I have to do this crazy thing? Like there's closures and closures and closures and closures. Like what is going on? I am lost. This seems hard. I don't want to do it anymore. So that may be the sequence of thoughts that you have, like jumping into back-end development, especially as you get into the more complicated areas of what you're trying to do. But let's go ahead and define some terminology. So Spencer, what is a future?
Yeah, a future is more or less this thing that says, for example, let's say you have a request where you it's a get request to the server, and maybe you want to get some JSON representing a model object, right? What would happen in the function that you write would say, okay, func get my model object or whatever. It would return this thing called a future with your model object wrapped inside of it, kind of more or less like an optional would. What that means, though, is that it says, I have this sort of thing that I will have in the future, but I don't have it yet, but I might, right? It's this like very nebulous concept where it's kind of like an optional. It might be there, but it might not be at any given time. And so what it will do is it will say, I as the developer, I'm going to write this function that says how to get from nothing to that something, whatever it is, in this case, maybe a model object. And eventually it will fulfill the future and say, yes, I have this thing now. Let's now give this back to whoever's requesting it. Remember that everything that we're doing, well, not everything, but for example, a URL request to a server is very much asynchronous. That's why we're always using, on the iOS side, we're using background queues. We don't know how long it's going to take. And so the future is really the thing that bridges this. Maybe I have 1,000 requests coming in at once and I have to, fulfill all of these requests, or maybe I have one. We don't really know. And so it's this nebulous amount of time. And so the future is saying, I will give you this thing back, just like give me some time, and eventually I'll give it back to you. That was kind of a long explanation, but
Yeah, so a future is an object that you get back when you make a request, and it doesn't exist yet. But it allows your code to continue working and doing other stuff, and chaining onto that future. So that's what I was talking about before, whether you have closures inside closures inside closures. You don't have to end up with that. So basically, a lot of Swift Neo, so this is part of Swift Neo, which everything is built on, but a lot of these asynchronous requests, they all return futures, and it immediately allows you to chain from one future to another. So once you get your future back, you can go ahead and add a closure to that future to say, okay, when the future is ready, go ahead and do this code. and that code will return a future, which means that after that code, you can add another chain to that sequence where it says, okay, when that future is ready, run this code. And then ultimately, you have one final future, and in Vapor, for instance, you would return that future, and then Vapor is going to hold on and wait for that entire sequence of events to finish. And then when it's ready, it will just send it out. So all your responsibility is to set up that chain and to transform what you're trying to do into a chain of events that need to wait for some values, because when you make a database request, that takes time. So you're going to be given a future, and then you just have to say, okay, I got my future. Let me put another request on top of that future for when it's ready.
Yeah. It's very much, I think of it as maybe a little bit more of an asynchronous way of doing, or a more asynchronous way of this example. But, if you just think about what happens when you get some, let's say, JSON back from a URL session request, right? It comes back as data, then you have to turn it into JSON. Let's say you're using JSON serialization. It comes back, as JSON. You have to turn that into a dictionary. Then you have to turn that into your model object or something. It's this multi-layer process or multi-step process, and the futures are more than anything just an asynchronous way of doing that. More or less using this kind of builder pattern to just chain things on top of each other, which honestly, the code isn't terrible, but like you said, there are closures within closures, and you start making requests to the databases, then you start sorting and filtering, and maybe having to, I don't know, do whatever, you end up with quite a few layers of this, or you can with closures.
And before it clicks, it's going to be messy. I can guarantee you, because Swift is going to freak out at one point. Like, I don't know what type any of this is anymore because you accidentally deleted a curly brace. So I give up, and then you, the developer, are like, I also give up, and then you sleep on it a little bit. That's how it's going to feel like when you start dealing with this. However, when you do get used to it and it does click in your head, because it will eventually click, you are able to write seemingly very nice and polished like chains of closures, and they're not inside of each other. They're just one after another. And it's gonna be like, oh, how did I not get to this before? Why did it not? Why doesn't it look so polished?
Right.
So
just think about like the first time that you were trying to learn the delegate pattern, or the first time that you were trying to learn how completion closure works. It's the same thing where you're like, this is so weird, but then you get used to it and you're like, oh yeah, this is no big deal.
And as Spencer mentioned, this is where Swift's new async await kind of comes in. You soon, and like this not yet, and for all sorts of reasons, Swift Neo can't go ahead and be rebuilt on top of async await, and it doesn't directly support it aside from a few helper methods. But in things like Vapor, soon you will be able to just use async await in those requests. So for instance, if you have a function that is listening for requests on /authenticate, for instance, that might be an endpoint that you have on your server. Traditionally, you might have needed to start off you need to wait for the data to come in and to decode that. It might be a big JSON, so you need to wait for it. So that's one feature. Then you need to kick off a database transaction to get the user's record. That's a second one. Then you need to communicate with another server to see if the user can access a resource, and so on and so forth. So you might have a few features kind of like intermingled there. What async await now allows you to do is you can go ahead and await the JSON data being available and just store that in a variable. And then on your next line, await the database transaction and just store that in a variable. And then on the next line, await the resource that you need to fetch and then store that in a variable. And you have 3 lines, and like your whole business logic is kind of there and happy. So I think that kind of fixes, like it's always useful to know what's going on under the hood with like futures, and we didn't even talk about promises, but basically a promise is a way of making synchronous code asynchronous. You basically promise to return something, and then sometime in the future you return it, and you can go ahead and switch threads and stuff like that. So it's an underlying building block, and you have futures and promises with the underlying building blocks of async await and Swift. You just generally never need to access them unless you're building up a framework yourself. So if you're just consuming other frameworks, super easy to do. You can get done in very few lines of code just by putting await on all those requests, and I think that is really going to make this super easy to start using.
Yeah, I think it'll just make it much more approachable because you're right. It really is like futures and promises that are the holdup, and they were the holdup for me in learning this. That was by far the hardest thing. But once you get past that, it's no big deal. You're learning another framework just like you do learning core data for the first time or learning, part of whatever. It's just another framework. Again, same language. That's the best part.
Same tools, too.
So yeah, same tools, right? We're all in Xcode. We can do Command R. We can do Command period to stop it. It all just feels natural and sort of native, right? So there's less mental overhead there of trying to learn how to use VS Code or whatever, right? So yeah, I think this is probably the thing that to me is the most exciting thing on the open source front that I really, really enjoy. Just so much potential there. It's a tool I actually would use. And it's really fun. Like you can, you've probably all seen the, whatever API, like the Pokemon API or the Star Wars API. It would not be that hard to build that out. If you had a bunch of information, if you wanted to make, I don't know, like a Mac history API or something, if you had that information compiled already, it would not be hard at all to throw those in a JSON file.
Exactly.
Yeah.
You can just throw it in a JSON
file.
file. Let it live in memory. Your app is not getting shut down between requests. It's living
exactly
there. So you can just throw that in data, and it's freely available. Everything you know about coding, about accessing arrays and data and JSON and dictionaries, all of that applies. With a sprinkle of concurrency that makes your life difficult because requests can come in all over the place. And servers tend to have lots of cores, which always makes things fun. But there are some good building blocks and tutorials out there to kind of help guide you on how to do that properly. And now with async await, that's made even easier. So it's something really cool to look forward to.
Yeah. We're now, like we talked about, at the point where Vapor's basically won out in sort of this server-side Swift race, I suppose, for as a web framework. So all of the resources, not just on the development of it, but the tutorials, like Dimitri said, they're all going towards Vapor. So you're not kind of competing. Other people are competing to make tutorials on different frameworks. It's all going to Vapor. There's a ton of resources to help you learn. Including like the one that I use to learn. I think it's been updated. They're pretty good about updating it. Is the Ray Wenderlich book. It's awesome. It was co-written by, at the time, I forget if it's Tanner Logan. I think it's Tanner. Tanner Mitchell, if I remember right. I can't quite remember.
Either way, it's been rewritten by Tim. So
yeah, and now rewritten by Tim, who are and were the main maintainers of Vapor. So it's coming straight from the source. It's as close to Apple documentation for UIKit as you could get for Vapor. So awesome resource. It's got some great tutorials, and it goes from, very basic, here's how to return something from a GET request to building out a database, deploying it. I think it goes into testing as well. It's a great book, and there are others from other people as well. That's just the one that I use. So like Dimitri said, it's nice to have this async await, but if you're interested, I would say don't even wait until async await is really kind of a part of Vapor in an official capacity. Go ahead and learn it right now and learn about futures, because ultimately that's what's happening under the hood, and it's good to know about what's going on there. And again, takes a little time, but you'll definitely get it, and it won't be much of a stumbling block anymore.
Yeah. So to give some context to what you just said in terms of like waiting, the async await stuff for the server-side community is kind of in beta up until iOS 15 ships later this year. So as the tools kind of get churn and exposure and people start trying stuff out, that is when Vapor is also going to be modifying and changing its APIs to better work with async await and stuff like that. So it is going to be changing. So it's almost better to kind of go in with what is there currently, get used to that, and then when async await kind of comes freshly baked and perfect at the end of the October oven, whenever new iPhones come out, that's usually when the OSs are kind of done. Whenever that stage is there, then you can go ahead and start using it, and it will feel refreshing because you will have used the old stuff, and you'll see how much better the new stuff can be, especially as people have started using it. And then in terms of Swift Neo, they can't use async await at a fundamental level because it's not quite geared and fast enough to fully support what they're doing. However, there are other features to the Swift concurrency story that are coming, likely in Swift 6, and when that time comes, they will be rewriting a significant portion of that underhood and that underbelly for things like Vapor to then start using. And at that point, we will likely not see promises and features anymore. But that will take some time. Like, we've been on Swift 5 for, I think, a year, more than a year, right?
More than a year, yeah.
Like, this is year 2 or 3 of Swift 5,
Yeah.
I believe. So it's going to be a while until Swift 6 gets here, but it's like the fact that it's not being rushed is appreciated, honestly. So it's something that will come little by little, and it's not going to come immediately. Just like in iOS and macOS development, you can't just go ahead and use async await if your app needs to run on older OSs. It's going to be a while until you can really start using it, especially if you already have an app out. And that's fine. Like, you don't need to jump on the new and shiny, especially when the new and shiny can change. See SwiftUI 1. Like, a ton of stuff changed and got deprecated. SwiftUI 2 was glorious by comparison. And SwiftUI, whatever we have right now and that was just announced this past week, kind of is a well-built thing that you can build pretty much anything on top of. So just like with that, it's going to take a while for this to really mature. So keep an eye out for it, like play around with it, but don't feel like you need to jump all in, because you don't. You can take your time. You can wait for it to mature a little bit more. And
Vapor itself, to be clear, Vapor itself is in that sense quite mature. Where
it's already 4 years old.
Mm-hmm. We're talking specifically about async await here.
Yeah, and I even mentioned last episode that like a combine might be at its final steps because async await is replacing it. And that just shows how little I know about combine. So combine actually provides a bunch of primitives for transforming your data at each step of the way. So async await is likely to make combine better and more useful, because then you no longer need to chain these promises and futures that combine vended. So publishers and stuff like that, those are futures. So you can then go ahead and chain them with async await instead of the native stuff that combine started with. So this all makes combine better. And the reason combine is not seeing much is because it's just a set of functionality. It doesn't need to grow over time. It's just being maintained as part, just like Foundation is. Like Array is not necessarily changing year over year like its internals are getting better, and it's likely the same for combine. So I take back what I said last time about it being a good thing that I never looked into it. I probably should have looked into it, because there are a ton of useful things that combine makes possible, and maybe now is an excellent time to look into it, because async await makes it nice and easy to use and not this foreign weird thing, just like server-side development might be. This week's episode is brought to you by Huuungry. Huuungry, that's Hungry with 3 U's, is the iPhone, iPad, and Apple Watch app you turn to when you really want to eat, but are blinded by the multitude of choices available to you, and your insatiable hunger. Huuungry isn't here to help you discover new restaurants or flavors. No, it has a much more humble purpose. You tell it all about your favorite restaurants, and it will deploy its cryptographically advanced random number generator, invoked by shaking your phone in frustration, to make the decision of what to eat for you. Stuck at home in quarantine and sick of ordering pizza? Use Huuungry. Did Huuungry just suggest pizza again? Don't fret, as options for another cuisine, a cheaper option, something closer, or simply another option are just a button away. Huuungry also comes with a collection of fun animated iMessage stickers so you can share your hunger with others. Thanks again to Huuungry for sponsoring our show. Search for Huuungry, that's Huuungry, on the App Store today to give it a try. So now that we've gone through our topics, it's time for Complete the Code, where we quiz our listeners on your knowledge of Swift, Apple, and all things development. It's been a while since we last had one, so let's go over our last one more time. Spencer?
All right. So we have 5 overloaded methods. The first takes a generic argument of type binary floating point. The second, a generic argument of type binary floating point and decodable. The third, a generic argument of type decodable. The fourth, an argument of type double. And a fifth, a generic argument of type numeric. If this method were called with the double as an argument, which order would the Swift compiler, rank the overloaded methods when determining which one to call? So that's kind of the prompt there. This is a bit tricky, but Swift prefers the most specific overrides first. So in this case, 4 would be preferred, followed by 2, then 1, 3, and then 5. However, if 4 and 2 were omitted, it would be ambiguous whether 1, 3, or 5 would be chosen, so the Swift compiler would give an error and force you to choose using as numeric, for instance. So that would be last week's prompt and kind of answer there. So this week's prompt is, we have kind of a different trivia challenge for you. So given a function called do the cool thing that takes 2 parameters, name and food, and returns a cooler thing, which key command in Xcode will build a template documentation comment for this function?
So can you complete the code? So tweet your answers to us with hashtag complete the code, all one word. The first to get it right will get a shout out on next week's show. And it's kind of inspired by, I don't know if we mentioned all the cool new things in Xcode 13 last week, but docc is a new format that Apple is pushing, and it seems to be exactly what they use to build their very first SwiftUI tutorials like 2 years ago. So if you enjoyed those tutorials, you can make the same like tutorial style very easily in Xcode 13 using the new docc format, which is a documentation compiler, and it will just run on in a web page or directly within Xcode. And makes it really easy to make tutorials and documentation, and like it's awesome.
That's exciting.
Yeah, I'm totally looking forward to kind of scrapping I have like a 200 pages document that describes the protocol we use at work, and it is a mess to maintain. So you know how like in Pages you can make a link to a different section? It takes Pages 10 seconds to load the list of bookmarks that I have set up. It's just such a large document. It's very nice looking. I'll give it that. But yeah, it is a mess to maintain. So I am totally looking forward to this and just moving everything over piece by piece.
That'll be nice.
Because then it's just gonna be a lot easier to maintain and to make links between things. So yeah. In any case, as always, I want to personally thank everyone for listening in this week. Be sure to follow us on Twitter at Code Completion to know when new episodes get released. And feel free to tweet at us if there's a topic you'd ever like for us to dig into. And most importantly, as a small podcast, please be sure to share this with your friends and family who are interested in any part of the process of app development. Even if you don't use Apple Podcasts, go to Apple Podcasts and subscribe and give our show 5 stars, or leave a review that tells us how we should change the podcast if you don't like it and you don't think we deserve 5 stars. Whatever you feel like needs to be done, but do go ahead and share your support there and then continue using your regular podcast player because Apple Podcast has been very broken lately. In any case, once again, I want to give my thanks to Spencer, who is at Spencer C. Curtis. That's SpencerCurtis on Twitter for joining me this week. My name, once again, is Dimitri. You can find me at Dimitri Buniol. That's DimitriBouniol. And we'll see you all next week.
Bye.
Bye-bye.